Now continuing with our deciding what the domain is, let's look at the square root of x minus 5. All right, so our only restriction here is we don't want negatives in the square root. So we need what's under the square root, x minus 5, to be greater than or equal to 0. We need it to be bigger than 0, or at least equal to 0, because 0 is okay under the square root. So this would mean we need x greater than or equal to 5. So if I wanted to state that as a domain, basically I could easiest to do this in just intervals, interval notation. 5 including 5 off to infinity. Okay. Now the last one here, so I have a couple of issues. I have the stuff in the denominator and I have it under a square root. So let's take a look at that 4 minus x squared. What do I need from this? Well, because it's under the square root, I need it to be greater than or equal to 0. But I don't want it to equal 0 because then I'd get a 0 in the denominator. So I need it strictly greater than 0. All right, and if I were to solve this, now that's a polynomial inequality. So if you wanted to solve this, you could go ahead and say that's 2 minus x times 2 plus x greater than 0. And then basically you'd be saying that we have negative 2 and 2. This is how we would solve this with the number line diagram. And if you figured out the pluses and minuses here, you would find that when you're on this side of negative 2, it's going to be negative. This side is going to be in the middle there, positive, and this side is going to be negative. And since we wanted this region in here, this is going to mean that we want to be between negative 2 and 2. So in fact, our domain would be open negative 2 to 2. Realize that negative 2 and 2 are both going to give us 0 for 4 minus x squared, which would give me a 0 under the square root. That's okay, but it gives me a 0 in the denominator. That's not okay. And anything outside of negative 2, 2 is going to give me negative under the square root, and I'm not allowing that because by default here, we're staying in the real numbers. Okay, so that was all about the domain. What about the range? The range is all possible values of a function considering the entire domain. This can be a little more difficult, much more difficult than the domain, because what I have to do is I have to think about if I take every member of the domain and put it in, what are all the possible outputs I get? And that can be tricky. Now it depends. Now for a simple function, it might be fairly obvious. So if we look at the function g of x equals x, all right? Well, in order to consider the range, we're going to have to think about what the domain is first. So the domain for g of x equals x, that's a nice little polynomial. There isn't any restriction on what can go in. So that's all the real numbers. So now, think about it. This function just outputs whatever went in. So if we're allowing all the real numbers to go in, then all the real numbers come out because what goes in just comes out, and our range would simply be all the real numbers. So that one wasn't too bad. Now, let's think about square root of x plus 1. Well, the domain here, since we have the square root of x, then that means that x must be greater than or equal to 0 because we don't want any negatives going into the square root if we're going to stay in the real numbers. So that means our domain is 0 to infinity. Okay, but what happens with our range? Well, we kind of have to think this out now. If we put all the numbers 0 and bigger into the square root of x, so first let's think about the square root of x itself. If we put all those numbers in, so if I put 0 in, I get 0 out of the square root. Then as I start getting a little bigger than 0, I get a little bigger than a value 0 out. All right, and that keeps going on. So just from the square root of x part, I also get 0 to infinity out. but then I'm going to add 1 to everything. So instead of my lowest value being 0, my lowest value is going to be 1 now. And in fact, my range becomes 1 to infinity. Now that wasn't so obvious there. And we're seeing that this is not a great way to go about it. Ranges can be difficult to determine. What we're going to do to make a problem like this a lot easier is use graphs to help us find the range. So let's look at the graph of a function. We've talked about graphs of equations, and this is very similar here. The graph of a function y equals f of x consists of all the points x comma f of x for every number x in the domain of f. So basically what we're doing is we're saying that every member of the domain, every x goes in, and for each one we record the output, and then we plot those as points. So what we're really seeing is we're seeing a whole function in a picture. So instead of just seeing the way the function is described, for instance, f of x equals x squared minus 1, we're seeing all of the inputs and outputs all at once. So I'm seeing that when I put 2 as an input to x squared minus 1, I get 3 as an output. So that point 2, 3 is 1 point corresponding to 1 input 2 and 1 output 3 for this function. But what's nice is it gives me an entire picture of the function at once. And further, what this does for me is it can actually tell me whether a graph is a function, describes a function y of x. So we can tell from a graph whether or not y is a function of x. That was something we were doing before sort of algebraically, and now we're going to do it graphically. So what does the vertical line test say? It says if this is a graph of a function y equals f of x, no vertical line will intersect the graph more than once. Right? It can intersect it once or not at all, but never more than once. So let's take a look. For this first one here, if we take a bunch of vertical lines here, notice that they always intersect the graph only once. And so yes, y is a function of x. Now look at this one. All right. So this one stops, well, it begins and then stops. So there are lines over here that don't intersect the graph. That's fine. That's intersecting 0 times. And here we have places where we intersect once, and then again places where we intersect 0 times. That's fine. Yes, y is a function of x. We only have to have the vertical line not hit more than once. All right, in this last one here, notice we have places where we don't hit the graph at all. We have one place along the axis here where we'd actually hit it just once, but then we have lots of places where we hit it more than once, and just having one place where we hit it more than once is enough to say, no, y is not a function of x. Okay, so the other thing, the graph, like I alluded to before, it's going to help us find domain and range. Now, domain wasn't really a problem before, but range was. So let's see how this can make this whole thing a lot easier. All right, so what is the domain and range of this function? Okay, so if we want to talk domain, we're talking about what's going in. What's going in, if we're talking y equals f of x, is x. So if I just look along the x-axis here, I can see that I start around -4, not at -4, because this is an open circle. So let me think, I start just past that, I keep going, and so I'm looking at any place where x values give me a place on the graph. Sorry, that should have been straight up. And so as I move along from left to right, I see that I keep getting all the values. I keep getting y values for my x's here, so they must be in the domain. Even at 1, I do get a y value here at 3, so that's good. And I get it all the way up to 3, including at 3, because this is closed. So this is telling me, I'm going to shrink this down a little bit. This is telling me that my domain is open -4 to 3 closed. Now if I want to look at the range, I look in y. Instead, I look along the y-axis. Now coming up from the bottom, you can see the first place that I start to get y values is near 1. So again, I'm going to say open there because that is open. And then I'm keep going up. Now notice I get y values for a while, from 1 to 3. I get at least 1. Now as I get to 3, I get the y values twice, but that's okay. And I keep going up, and where's the highest y value I get? Is up at 9. And I do get it because, again, it's closed. So this is really telling me that my range is 1 open to 9 closed. All right. So I was able to find the domain by looking at what's covered in X, and the range by what's covered in Y. And that's how I can use a graph to find domain and range. Specifically, it's a good way of finding range.